All right, everyone. I am here with Akshat Kaul. Akshat is the head of data and machine learning at Redfin, where he oversees the data engineering, data platforms, and ML teams. Akshat, you've been there since 2016?
Yep, that's correct.
Awesome. Awesome. Well, welcome to the podcast. I'm looking forward to digging into our chat.
Yeah, absolutely. Thank you so much for inviting me.
Uh, yeah, I know a bunch of folks at Redfin. I worked at a company called Plumtree previously, so I know Bridget and Glenn, and uh, I imagine a bunch of other Plumtrevians are still at the company. So I'm really looking forward to digging into how machine learning is used at Redfin. Um, can you start us off by maybe giving us a little bit of history of ML at the company?
Sure, yeah, absolutely. So I can talk a little bit about Redfin first. So Redfin is a real estate brokerage founded by software developers, and we use technology to make everything about buying or selling a house better, more efficient. We have saved our customers a lot of money, like more than $1 billion in fees over the years, and we have tons of really unique and interesting data about real estate transactions and people who are interested in buying or selling homes. And we rely quite heavily on AI in many parts of the business. So there are tons of use cases that we have. We've been investing in machine learning for quite some time. So things like the Redfin estimate, things like Redfin recommendations. There are other use cases also like hot homes. So yeah, we have unique data, we have interesting data, and we have some really interesting use cases.
How long has the machine learning team been in place at the company?
I think it's been there like longer than I have. So I joined in 2016, and I think machine learning team existed probably like 2 years before that. So almost 7 8 years now, I think.
Okay. And since you've been leading the team, tell us a little bit about the evolution of ML there.
Yeah, absolutely. So I think when we started, like when I initially, joined the team, we basically had this model where there was one team, sort of one consolidated team that did applied machine learning in the company. So all machine learning use cases would be built out by this team. It's a team of really special people. It's a team of really smart engineers. They are data scientists and engineers rolled into one. So they are machine learning engineers, and they were not just building machine learning use cases and applications like the Redfin estimate, for example. They were also building the underlying infrastructure. So the model was that you would give somebody a problem and they would go in and solve it, developing the infrastructure along the way. And this worked reasonably well for the company for quite some time. But we had come up to the point where this was not really scaling. So we had gotten to the place where Redfin was involved in multiple businesses. It was not just a brokerage. We also had an instant buying business. We have a mortgage business. So we have all these tons of use cases across different domains. And so it didn't make quite so much sense for just one team to be sort of the choke point of machine learning at the company. So what we've been trying to do more recently is really develop that infrastructure, make it standardized, make it easy to use, and really democratize machine learning within the company and allow teams across the business, across different domains, to hire people who have that machine learning talent or to grow that talent, and then use the platform that this team has built to tackle use cases in different domains. So that's what we are trying to get to, where the best practices are established, and there is a standardized platform that everyone can use. But it's not just one team that's actually building the applications.
Got it. Got it. So then your team is providing that kind of tooling and infrastructure, and the individual application teams or business teams have the data scientists and the machine learning engineers that are actually building the models.
Yeah, it's so certain applications are still owned by this sort of centralized team. So the Redfin estimate is an example. Redfin recommendations is an example. So there are certain use cases which sort of cut across multiple domains and multiple businesses, which is handled by this team. But the platform itself is available for anybody to use within the company, and we are encouraging people to build use cases using the platform.
Awesome. Awesome. Well, let's maybe talk about the two central use cases to get started. Redfin Estimate. Tell us about that.
Yeah, absolutely. So the Redfin estimate is a machine learning driven calculation of the market value of any given home. And we have the Redfin estimate for pretty much every home that's both on market and off market within the US. The Redfin estimate factors in more than 500 data points about the market, the neighborhood, the home, and other things about so things like how many bedrooms and bathrooms it has, what size the home is, as well as like broader market data about how home prices have been trending in the county and the state. And it looks at what comparable homes in that neighborhood have sold for recently. So it puts all of this together to come up with a value for what a particular home should be worth. And yeah, it's been a really tremendous tool for Redfin. So traditionally, it was something that we were using mainly as a growth driver. So people were really interested in knowing the value of their home, as you can imagine. It's one of the biggest assets that most people own, and so they would come to Redfin to see what the value of their home was. But more recently, as Redfin has gotten into the instant buying business called Redfin Now, where Redfin actually buys homes and makes improvements and then sells them. So that business is also heavily reliant on the Redfin Estimate, and so Redfin Estimate has started to have a significant impact on both our user growth and also our revenue.
You mentioned that 500 data points kind of go into this calculation. Are those, tell us a little bit about the data sources that those data points come from. I imagine the MLS is one major source of data for you, but I can't think of 500 points of data in the MLS, so there's got to be others.
You'd actually be surprised. The MLS has just a tremendous amount of data. Actually, the MLS is the multiple listing service, which is the database uh, of all homes which are coming on the market. There's also properties data, so that like there are county records which have data about what a particular home sold for, the history of the price of that home, and it has information about the MLS has information about amenities that that home has access to. There are other sources of amenities data that we use, like how close is the closest Starbucks to a particular home, for example, or are there accessible recreational centers that are close to the home. So things like that also factor in. Then we have sources of all kinds of geographical data, so that we have things like flood zones, for example, and of course we also have tons of data about user engagement. So redfin.com is actually the biggest brokerage site in the US. So we get more traffic than any other brokerage site. And so we also have data about what areas people are actually looking at for buying homes. So we know what the competitive landscape is in a particular area. So that also factors into one of those some of those 500 data points that we have about a particular home as we make the estimate.
I think it's probably pretty common for us to think of, in the case of like a Google search, that the user interactions with the site kind of inform, which content is most relevant, and that those would shift the rankings. I don't know that, um, I would have guessed that the user interactions with a site like Redfin would impact, my home value on that site, or the estimated home value on that site. It's I guess it's kind of prompting questions about, like, how do you monitor for abuse of that, if people can kind of, send bots to the site and manipulate home values. Is that a thing that you think about?
Yeah, certainly something that we think about, and we have lots of mechanisms in place that prevent some of that bot activity. So our website has ways to detect it. We have ways in which we would, for example, we would prevent somebody who's coming in from AWS, for example, or like a VPN, using a VPN. We would be able to detect that this is a machine, instead of like this traffic is coming from a machine instead of a person potentially. And we have means of eliminating that data. But it's only one factor in a lot of different factors, like
Mhm.
this traffic data, the impact it has on the price of a home. There's also like after a home has been on the market for a certain amount of time, even if it's getting tons of traffic, like it is likely that the competitive landscape for that particular home is not, like, at the price at which it is listed, is maybe maybe not the right price. So we can take that into account as well to make sure that the Redfin estimate remains accurate for listed homes.
Yeah, yeah, no, I think that's a great point. The ability to use machine learning to incorporate a ton of points, potentially reduces the sensitivity to an individual data point. I think probably a lot of folks, listening to this interview have kind of done the build a home price estimate,
Yeah.
build a home price estimate model based on the Kings County data.
Yeah.
Like that was a classic for a really long time,
Yep, yep,
where you're looking at like the square footage and the number of bedrooms and bathrooms.
yep.
But we're well beyond that. Can you talk a little bit about the types of models that you are using to produce the estimate? Is it deep learning, for example, versus more traditional types of
Mhm.
models?
Yeah, I think we use a combination of like classical models and deep learning models, for various things that we do in the business. For the Redfin estimate, like we have models which predict off-market homes. We have other models which are predicting the price of an on-market home, a listed home. And as you can imagine, the ones for the listed home, it's more of a real-time model. The so yeah, we use a combination of many different techniques, random forest, we use gradient boosting, we use deep learning in some cases. So yeah, it's a fairly complex problem, it's a fairly complex model, and we use a multitude of techniques to make the estimate as accurate as we can.
Hmm. And one of the things I've seen in this space is kind of a heavy use of hierarchical or ensemble types of models. Like you have a bunch of data points that, for example, predicts something akin to a walk score, and then you feed that into a higher level model. Are you doing that kind of thing as well?
Yeah, we do have ensemble models as well as a part of the overall picture. We get data from tons of different sources. We have like, we also have multiple estimates that we combine sometimes to get to the perfect value for different use cases again. So yeah, we certainly have a bunch of different techniques that we use across the business.
And then beyond the estimate, the other model that you mentioned was
The other big one is home recommendations.
recommendations.
um,
Okay.
yeah.
And that's the
So
recommendation that a user would see in their feed or other homes you might
mhm.
like when they're viewing a home on the site.
Yeah, absolutely. So we both have a feed on redfin.com. So the first page that most people see is a feed that is a list of recommended homes that Redfin thinks that they might be interested in. We also send out emails and push notifications about homes that Redfin thinks somebody might be interested in. And the home recommendations tool is like a really valuable and popular feature for people who are searching for homes on Redfin, and it's really tremendously helped us grow our business. So just to throw a few numbers out there, uh, when I joined Redfin initially, like 5 years ago, recommendations was driving about 8% of our overall traffic, and it is now close to a quarter of our traffic, even while our overall traffic has grown by three times of what it was 5 years ago. So that gives you a sense of just the importance of recommendations to the business. Also, some really interesting things we have seen is that people are more likely to click on homes that we recommend to them than they are on homes that match their own saved search. So it's like uh, we like the recommendation system is actually better at predicting what homes people will click on and what homes people will tour than saved searches. So saved searches, of course, like when somebody goes to redfin.com and tells us this is the price range I'm interested in, this is the area I'm interested in. But yeah, recommendations work even better than that. So it's just really amazing to see. And it's come to the point where now people expect us to know what they are interested in without them having to tell us their preferences explicitly. which is just a change in consumer behavior, right? So it's people are they just want you to have a recommendation system that works very well for them. And also, one thing we've noticed is that recommendation systems, at least in the interactions that we've seen, they keep getting better as people engage more with them. So the earlier you get started as a business on setting something up, um, is the more value you get out of it in the long term.
One thing I've noticed, this is not something that Redfin does, it's something that one of your competitors does, is that the recommendations seem to promote a price creep, like a budget creep. Like you identify, you might say in your search that, you're interested in homes within a certain price range, and it starts showing you those. And then gradually it starts showing you more and more expensive homes. I'm wondering, with that as kind of a general example of, I don't know, responsible AI, or maybe a broader question is, in what ways does responsible AI play into the way you think about models at Redfin? And how do you approach the topic?
Yeah, I think that's a really, really good question. I think what you're talking about here is also how does the market itself get defined by these algorithms, right? So if we start to recommend homes in a particular neighborhood, do those homes become more valuable, um, and things like that. So I think that's certainly a really interesting topic, and how we generally approach this, like the idea of building models which don't have biases, or building models which don't create biases in the market. We are very careful about what data we add to the models. So we don't want to whatever the model learns based on what data you give to it. And so what we try to do is, we try to explicitly not put certain types of data into both our recommendations models and our estimate models. So for example, crime data, it's not something that we would put into the model, because we believe that it might create some inherent biases in the data which we don't want it to have. And as far as like price creep is concerned, like sometimes there is always an element of exploration and exploitation when you're doing machine learning. So it's possible that I don't want to speak to what our competitors are doing, of course, but there might be some element of okay, we'll for X% of times we might suggest a home that is outside the price range that a customer might have specified, just to see if that is actually interesting to the customer, to the user. And that way the model learns about their preferences. And sometimes, certainly for me, I can tell you my own story. Like the region, the area that I was looking at to buy a home myself, was I was looking in the Seattle area. And uh, like there were this, and my main criteria in my mind was like, can I commute? This was pre-pandemic. So can I commute to work? And I didn't even know that there were these areas where I could actually commute to work outside of Seattle, the areas outside of Seattle where I could actually commute to work within the same time frame that I had in my mind. And the recommendation system was able to figure that out, and make suggestions. And so I ended up buying a home in the greater Seattle area, as opposed to within Seattle, just because my own preferences did not take into account this additional information that was outside of my view.
Yeah, I'm curious the degree and the ways in which the pandemic impacted machine learning at Redfin. Clearly, it impacted the real estate market, clearly impacted the company as a whole. How about from an ML perspective?
Yeah, absolutely. So this is a really interesting topic. The real estate market as a whole was impacted in really, at least for us, like unpredictable ways. It was not something that people expected to see, that the price growth would happen at such a rapid pace. So just to give you some background on the broader market, we have seen earlier this year, in May of this year, 26% growth in home prices across the country year over year. Over the like in certain markets, it was as high as 40% year over year growth. And even in August of this year, it was still about 16% year over year nationwide. and 60% of homes were being sold, within 2 weeks of being listed. So it was a really competitive market. And also, we saw that one really interesting thing that we saw was that 63% of home buyers were making offers on homes even without stepping foot inside them. So this is a complete like change from how things were before the pandemic. And as you can imagine, this made it really important uh, for us to have an experience on the website where people could get the sense of what it was like to be inside a home without physically being inside a home. And so we already Redfin already showcased 3D scans on the website quite prominently, and we already created 3D scans for every Redfin listing. But to really help our customers understand the physical layout of homes even better, we started automatically tagging all floor plan images using computer vision. So that was one very clear connection to machine learning. We invested quite heavily. We started generating a lot of image tags, and generally starting to come up with ways in which we could extract unstructured data and present it on the website in a structured form. And that was a big investment that we made. Another really interesting thing that we saw was that because the market was so crazily competitive, you had to, like, if you were really interested in buying a home, you had to get in as early as possible. So you wanted to be one of the first few people who put in their bids on a home. And in order to identify homes which are likely to sell really quickly, we have this feature called hot homes on Redfin, which is very much a machine learning driven feature. So certainly, speaks to the topic of machine learning and the pandemic. So the hot homes feature, as you can imagine, it takes into account things like user interaction, but user interaction takes a little bit of time. So a home comes on the market, we observe how many people are clicking on it, touring it, things like that, for a couple of days. And then the hot homes would tag a home as a hot home. The hot homes model would tag the home as a hot home. Um, the What we wanted to do was to make it even faster. So we wanted to have a model that would uh, tag a home as a hot home as soon as it listed. So even without having that user interaction data, we wanted to be able to tag it. So we built a model which is a days on market model. So it's like it predicts how many days on, like, a particular home is likely to stay on market based on its price, based on the home characteristics, based on the neighborhood, things like that. And then we reused that days on market model to start predicting hot homes early. So we call it the early hot homes model. And it as soon as a home lists, in many markets now across the nation, we are able to tag a home as a hot home and give Redfin users an edge in being able to get in early and start bidding on homes.
You alluded to this earlier, the impact of Redfin on the broader market, and I'm wondering, the extent to which and how you might go about studying the impact of identifying a home as a hot home on the
Mhm.
market.
Yeah, so we definitely, we like the model is also trying always to be as accurate as possible. Like we look at precision recall at the time when we are training the model, but we also keep an eye on precision and recall. Like we have ways of measuring error for these kinds of things, right? So if we predict a home is a hot home and it doesn't actually sell within 14 days, then we want to make sure that our model knows about that, and we want to retrain our model with that new data. So we are all of our models, including the estimate, we are measuring the error that we see compared to the real world results of what actually happens to that home.
When the pandemic hit, to what extent was the your response to that, either, hey, we always retrain our models, on a periodic basis, weekly, whatever, and they just will automatically adjust, versus, you just talked about the error, you're monitoring the error, the pandemic threw the errors out of bounds, and then you selectively retrain, versus just kind of more of a top down, hey, the world is upside down, we need to look at everything differently.
Yeah, yeah. So I think it was a combination of both those things. So as you said, we do retrain our models on a regular basis. But we found that because the market was upside down and crazy, like completely crazy over the last 18 months,
Hmm.
um, we did decide to selectively retrain certain models on a greater frequency, even though retraining models is a costly thing. So it adds additional operational cost. But we did decide that retraining our models more, particularly the Redfin estimate, more frequently was required to keep up with the dynamic, fast-paced market that we have been experiencing through the pandemic. So I think that is what I was alluding to in terms of the effect on the Redfin estimate. Like, we have been retraining it much more frequently, and we have seen significant improvements in accuracy based on that change.
Got it. Got it. And going back to our conversation about models and maybe tying into the previous question about the hot homes feature,
Mhm.
to what degree have you explored causal models to identify or take into account, linkages between things you do on the site and the impacts they have in market?
Yeah, I think we have been looking into causal models. It's a hot topic in machine learning right now. Um, I, I think, yeah, we are exploring some ways in which they can be used to improve the accuracy of our hot homes predictions. So it's still like it's an ongoing effort. Like, we are always we are always working on improving the models that we have in production, and that is one of the areas we are exploring.
So you mentioned there's maybe some interesting background in the pandemic impact on the estimate.
Yeah, I think we talked a little bit about it just now, where we have, we started retraining our models more frequently. We also saw that certain regions had a significant certain, or rather, I shouldn't say regions, I should say certain types of homes had more of a change in price compared to others. So, for example, single family homes became a lot more valuable compared to multi-family homes or condos, or places where people were scared of being being surrounded by other people, which the pandemic tends to bring out that kind of behavior. So we saw that because the types of home that the type of the home has such a significant impact, we started looking into other types of features that would focus more on home, like on the characteristics of a home. We saw that the weighting of some of those features started to get more and more during the pandemic in the model. So that was again something more of an observation, I think, than something that we had to step in and change. But that was another thing that we found was interesting. Like, it was the pandemic was revealing certain preferences which are different from how they were before the pandemic began.
I'm curious about some of the smaller use cases at the company that are more driven by the specific teams as opposed to these two larger ones. What are some examples of those?
There's a new team that we have had for, I think, like the last year and a half, 2 years, and it's called the document intelligence team. It's a separate team from the main applied machine learning team, but they are focusing very almost exclusively on how to extract information from real estate transaction documents. So we have tons of this really interesting data that very few other companies have, because we are a part of the transaction, the real estate transaction, and we are part of like tons of real estate transactions. So we have lots of deals happening. We have a lot of PDFs. We have a lot of this unstructured data sitting in these files, and we wanted to have a mechanism for extracting useful information from those files. And we also wanted to have build tools that would help our real estate agents deal with these documents in a really efficient way. So we created this, like, a bunch of these tools that would do OCR on these documents, that would extract useful information from these documents, that would perform all kinds of checks to make sure that the data that was in those forms was accurate. Because if that data is not accurate, the transaction, the deal, can fall through, and that or get delayed, and that's not ideal for any for any customer who's in the process of spending sometimes millions of dollars on a transaction. So that's been one really interesting use case. Another really interesting use case has been the there are all these tools that we build uh, for our agents, which help them become more efficient. um, and there is one particular tool, it's called the comparative market analysis. So that's a smaller use case, I guess, compared to these other two big ones, but that's also a really valuable use case for the agents who actually need to work with customers directly. So when a listing agent is talking to a person who wants to sell their home, uh, after they finish talking to them, the next step is usually that they would write up a comparative market analysis, which is a document that describes these are the other homes in your neighborhood, this is how much they have sold for, this is what the landscape looks like, so this is what you should price your home at. And that document, it's called the CMA. So agents typically spend a couple of hours on building out that CMA, and they share it with the customer after they have that initial consultation. But because we have the like this investment in machine learning at Redfin, we are able to generate that CMA automatically even before a real estate agent actually talks to a customer. So that gives them an advantage, that saves them a lot of time, and that again brings in a lot of efficiency into the whole business of running a brokerage.
Yeah, I'm curious the degree to which you've explored language models for text generation. I can imagine, creating listings, things like that. Is that something that you've looked into much, or are you using it anywhere in the business?
So I think we are not using generative models so much in the business right now. One area where I'm a little bit of a of a skeptic, I guess, is conversational AI. So I think that's one of the places where a lot of people do get excited about using generative models. Like I think like we are not really at that place yet where conversational AI is good enough to be included in high value transactions like real estate. So I don't think I would want to, like, if I was buying or selling a house, I don't think I want to talk to a chatbot agent, for example.
Yeah.
Um, so what we do instead of building chatbots for customer service or for real estate agents, we instead focus on improving the efficiency of humans in the loop. We build tools for them to be able to do their work more efficiently. We build tools for them to be able to explain how the Redfin estimate works, for example. So we like there's accuracy and there's explainability, and sometimes those two things are at odds, right? So
Hmm.
we have tools for helping explain what goes into the estimate. If somebody comes and tells us, like, calls our customer service agent and asks why is my home priced at this price, our customer service folks can tell them these are all the inputs that go into the model, and if any of this data is that Redfin has about your home is inaccurate, you can tell us, and we can make a correction. So that's mostly been the focus of our machine learning investments as opposed to conversational AI.
I want to maybe shift gears and talk a little bit about the platform and tooling that you've set up to support modeling across the business. Can you give us a broad brush landscape of the way that you think about ML ops and tooling in general?
Yeah, absolutely. So, as I said, we have made recently a big investment in building machine learning tooling, making a really easy to use machine learning platform that people across the business can use, even if they don't have already have like a great deal of expertise in machine learning or the right talent. They can actually go, teams can go and hire that talent and start using this easy to use platform. We call our platform Redeye. And it is not it's we are not trying to build the like a ground up, like, base level machine learning platform where we are not trying to sort of recreate SageMaker, for example. What we're trying to do is bring together all of these already existing tools that exist outside of Redfin, like that exist within AWS, within GCP, and we want to bring all of those in. We want to create tools that make it easy for those things to be used with Redfin data, and we want to establish standard best practices around how to do experimentation, how to do prototyping, how to actually push a model that has been prototyped into production. So that's been the focus of the Redeye initiative. The specific tools that we use, like we have started using Airflow, we have started using MLflow quite extensively. So this we have our own sort of feature library. We call it internally, we call it Ohara, but it's a combination of a feature library and a data catalog, so people can easily discover the features that have already been engineered by their colleagues at the company for other kinds of machine learning use cases. So all of this in combination is what we hope is going to really make it very easy for every engineer at the company to start working within the ML ecosystem. And yeah, that's what our vision is.
And is the feature library kind of bottoms up homegrown, or is that based on open source or commercial offering?
I think it's mostly homegrown. So it is like we have all this data that we have all these Hive tables, Spark tables, data that goes into that like it was all kind of spread across and not very well organized, and we decided to organize it in a way that makes sense and that can be makes that data reusable. So we haven't invested heavily yet in sort of open source data catalogs or data organizations because we don't haven't found the need for it yet. But we have been exploring some of those things, and we're certainly open to investing in them if they make sense for our use cases.
When you think about the platform that you're building, who is the target persona, or who are the target personas? Are the users there more kind of classical, data scientists, not particularly uh, infrastructure oriented, aren't native Docker users, that kind of thing? Are they more the ML engineers that are more comfortable with those kinds of things? How do you, oftentimes, platform teams are trying to balance,
Mhm.
who they're building for and those personas. How do you think about
Yeah,
that?
yeah, absolutely. I think yeah, you said something. Yeah, you very insightfully explained the various personas, and that is exactly how things are at Redfin. Also, we have people who are data scientists who are maybe more comfortable with R than with Python. They might be folks who are not quite as familiar with some of these tools which machine learning engineers use. So our platform is geared towards serving both those types of customers. So we want users who are we have power users who are machine learning engineers, and the platform supports their use cases. They can build like really large scale models. They can go in and they can use all kinds of different tools, deep learning tools sometimes. We have the same platform serving our complex use cases like recommendations and the estimate, and we also have the same platform serving uh, BI focused use cases, for example. So we are trying to build something which caters to both of these kinds of customers, but our two big personas are folks who are more BI focused, who are data scientists maybe who work within R, and we allow for them to be able to build models that can go into production, or we allow for them to build models that can have APIs built in front of them that can be productionalized. And we also cater to more hardcore machine learning engineers.
And you mentioned Airflow and MLflow as some of the tools.
Mhm.
Is the implication that your platform today is more focused on kind of the experimentation and model building phase, as opposed to, other organizations emphasize the, push one button and a production instance of a predictive service is spun up?
Yeah, yeah. So I think I'd say we are trying to cater to both. Like Airflow is not just for experimentation. Airflow can also be used in production. Like it's an orchestration platform that
Hmm.
um, powers many of our production workflows. Like previous to this, we had our own homegrown orchestration system, orchestration platform, and that was it was getting like really cumbersome and hard to manage. Like we had a really complex graph of services which were all involved in finally serving the Redfin estimate or the home recommendations. And we had like these lambda functions, talking to each other across multiple services. It was very complex. It was hard to maintain, and so we decided we would standardize over Airflow. And we use it, as I said, both for building experimentation pipelines, and we also use it for building production pipelines. MLflow, of course, is very helpful in experimentation, but Airflow is useful for both.
I alluded to kind of Docker and Kubernetes earlier. Is that a part of the tool set there?
Yeah, absolutely. So we, as a company, we are investing quite heavily in Kubernetes, like not just for machine learning, but across the business. We are building a bunch of platforms that run on top of Kubernetes. We actually explored Kubeflow before we, initially when we were starting out, we explored Kubeflow. It was a little bit more complex than what was needed for, I think, for supporting the platform that we have. It comes with like you have to have machine learning engineers who are also Kubernetes experts if you use Kubeflow right now. Like I think that's where the state is of the world is. So we ended up running Airflow in Kubernetes, but not using Kubeflow. Maybe we'll come back to it in a couple of months or years and see if it makes sense for us then. But at this moment, like we are using Kubernetes, but we are sort of running a hosted version of Kubernetes, and most of our energy goes into maintaining Airflow on top of Kubernetes as opposed to maintaining Kubeflow.
You've referenced the cloud and cloud services several times in our conversation. SageMaker, GC, GK, that kind of thing. How do you think about the role of the cloud in delivering the platform for your users, and more generally, uh, deploying, building and deploying machine learning?
Yeah, I think it's really like it's almost impossible to do machine learning right now without some kind of reliance on cloud services. So traditionally, like before SageMaker and AutoML existed, people would use EMR on AWS. Even before that, people were like deploying Hive on EC2, EC2 instances on raw EC2 instances. So things have continuously progressed over the last few years to make it easier and easier for somebody who wants to build a machine learning model to get to the point where they have an actual model running in production, or running for an experiment, prototyping in the cloud. And like I think what we have seen, what we usually see is that um, it's there's like always this uh, like if you use some of these more advanced, more out of the box services like AutoML or SageMaker, it is much faster to get to production, but it is also much more expensive. So it ends up you usually make this trade-off at the end. Like you try a bunch of things out, you see what works, you try things out on AutoML, you try things out on SageMaker, you get to a point where you have a model that works, that gives you good results, and then you start to optimize on the operational cost. So then you see, okay, does it make sense to invest some time now into uh, building something more bespoke, see if that saves enough operational cost to justify the cost of actually investing and building that model. So that's how it's been for us. Like we use a combination of all of these services. Some of our stuff still runs on EMR, and it is actually cheaper to do that sometimes than to use SageMaker.
And I'm glad you brought that up. When you were referring to the document intelligence tools that you were building, I was thinking, well, all the major cloud vendors have kind of these document AI services that'll do OCR. And as you described it, it sounded like you were going for a level of integration, or kind of custom feature that may not be supported by them, but also at some point your cost is going to be expensive, kind of operating using one of those higher level services versus building it out at a lower level infrastructure.
Yeah, yeah, absolutely. So it's always, there's always that, you have to make that trade off. And yeah, we certainly, like, I don't think, like, we are not, the document intelligence team is not creating new OCR libraries. They are using, standard OCR mechanisms. So yeah, I think there's always this trade off. They might have started with, looking at the document intelligence services that some of these cloud platforms provide, and then, eventually they evolved to a point where they were using either a combination of those services with some more homegrown stuff, or sometimes moving to a model which would be operationally a lot cheaper, especially if they are deploying a model and like doing inference at scale, where they are using something more bespoke.
Where do you see the platform going at Redfin, and even more broadly, machine learning going at Redfin?
There are like a really a ton of really interesting use cases where we are hoping to spend, more of our energies. So I'm talking more about like machine learning at Redfin now. So there is, as I said, there are all these really interesting unstructured data that we have access to, in terms of, there is this language, there's all this stuff in the properties, in when a home comes on the market, like marketing remarks have a ton of really interesting data, images have a ton of interesting data. So we expect that we'll be using computer vision in a quite an extensive way to improve the accuracy of the estimate, into improving the relevance of our recommendations. um, and we hope that at some point we can uh, start to figure out home conditions even better than maybe humans can, based on all this unstructured data that we have about properties. So that's one area in which I see a big investment, like computer vision. Another area is, there is this really a lot of interest in making the process of touring homes a lot easier. So there is a lot of coordination that happens when somebody wants to tour a home. You have to talk to, multiple people, including the obviously the person who wants to tour the home, the agent. Whether that home is available or not needs to be figured out. So there are certain use cases there which, would be maybe good places for machine learning to be used. And I think more broadly, like the business of mortgage is something that is probably going to have some really interesting, use cases where we can expect to see some investment within the company. So yeah, this is like, there are just a ton of open areas within lots of different domains, um, also including the instant buying business, where I'm expecting that we'll see a lot of new investment. On the platform side, we are getting close to the point where we have a platform that is quite easy to use. We are investing quite heavily in, building labs. So labs as in like documentation, and making it easy for people to understand how to use that platform. So that's another area where we are going to spend a ton of our time, just to make it, really easy to use, make it possible for someone who maybe has a basic understanding of machine learning and has, taken the courses, but hasn't really started to apply that knowledge within the Redfin context. So that's another area where we, expect we'll be doing some work.
Awesome, awesome. So big focus on onboarding
Hmm.
engineers and data scientists onto the platform.
Yep, yep, absolutely.
Great, great. Well, Akshat, thanks so much for joining us. It was wonderful to learn about machine learning at Redfin.
Yeah, thank you, Sam. It was a really interesting conversation.